Hi, and welcome back. Until now, we have understood functions and we have looked at different types of functions, correct? And we have also looked at how to prove one function and onto function. We're going to continue doing that. We're going to do a few more questions from the exercise 1.2 of the NCERT textbook, and we are going to understand how to prove one and onto in detail. Okay, so let's pick up the question from the NCERT textbook. Okay, you see it says check the injectivity and surjectivity of the following functions. What is injectivity? Basically he's asking me to check if this is a one function and onto function. Alright, so let's pick up the first question here. The first one, this. Okay, right, now let's go ahead. What is the function for us? The function, if you remember, it was from n to n. That's the first thing that we need to understand. Okay, it is from natural numbers to natural numbers, and the function is given to me as f of x is equal to x square. F of x is equal to x square. Okay, great. Okay, so let's check if this particular function is a one function and an onto function. First of all, is it a one function? Let's see. So natural numbers on either side. So the function is from natural numbers to natural numbers. Again, as I've been telling you, this is a bold n, so I'm going to write a line right next to it. Okay, to tell the reader that I'm writing the natural numbers n. Okay, so this is going to have 1, 2, 3, 4, 5, 6 and goes on till infinity, and this also has 1, 2, 3, 4, 5 and goes on till infinity. So I'm going to take a number from natural numbers and square it and connect it to the square of the number on the other side. So 1 square is 1, 2 square is a 4, 3 square is a 9, 4 square is a 16 and goes on, isn't it? So is it a one function? Yes, it's a one function because the square of a natural number will be a unique number. It cannot be anything else. So what am I saying? Like 4 square of a 4 is a 16. It cannot be a 18. Correct? So that's exactly why this is a one function. But is it an onto function? It's not an onto function. You can see here 2 and 3 is left out. What when squared in the natural number set will give you a 2 and 3? Nothing. And exactly why this is not an onto function either. Oh, it is a one function but not an onto function. Okay, let's go ahead and prove this for 1. What do I have? The procedure is very simple. First of all, you need to consider two elements from the first set. Okay, so let x1 comma x2 belong to n. Okay, then you put a condition that let f of x1 be equal to f of x2. Here I'm actually meaning that the images of these two are the same, which means now I'm actually saying that this is a onto function. So which ideally means that x1 square is equal to x2 square. Correct? Now after this I can write x1 square or x1 itself, not a square, just a x1 as equal to plus or minus root of x2 square, which gives me x1 to be equal to plus or minus x2. That's it. Okay, but the function is being defined from natural numbers to natural numbers, isn't it? And exactly why I cannot have a negative, and therefore x1 is equal to x2 as the codomain is n. Getting me? And now since I have proved x1 is equal to x2, therefore f of x is 1. So now for me to prove that the function, in fact this is not an onto function, and the proof is very easy for onto. Okay, 2 belongs to n, isn't it? Which is a codomain. But there exists, but we're not going to use that because you don't learn it. So I'm going to erase this for you. but there exists no element in the domain such that no element, let's say A, in the domain such that A square is equal to 2. Getting me? Therefore f of x is not on 2. Okay, you can prove it this way, or you can also try and prove it in a different way, but that's going to be a bit lengthy method. I'm not going to do that. I'm just going to leave it like this. Okay, so that's it. Now let's look at another question. Okay, now it's the same function. In fact, if you see, the first 3 questions are the same. The function is the same. This is x square, this is also x square, and this too is x square. The only thing that is changing here is this, the domain and the codomain. The domain, codomain, domain, codomain. This is changing. Okay, so I'm going to take the same function once again. Alright, now I'm going to put a different color to this. This one I have proved in white, so I'm going to now pick up let me pick up purple. Weird color to choose. Let me pick up a blue. Blue will be fine. Okay, and let me see if it looks good. Yeah, it looks fine. Yep. Alright, let me erase this. Okay, so the function given to me was from this time it was from integers to integers, and the function was still the same. F of x is equal to x squared. Okay, now let's understand this. This is from integers to integers, correct? Okay, so alright, so this is going to have minus 2, minus 1, 0, 1, 2, 3, and it goes on till infinity here, and it goes on till infinity here, and here too I'm gonna have something like let's start from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, and probably I think I have to extend this. There's a reason why I need to extend this. I'll let you know. First I'm going to write the elements and then think about 5, 6, 7, 8, 9. I think I'm going to start with 9. Okay, it goes further because it's not going to stop here. It's simply going to go further, and this also is going to go further. Okay, now take an element from the first set, which is the integer set of integers, and connect it to the square of it on the second set, which is again the integer. So the square of 0 is a 0, so it will get connected to 0. The square of 1 is 1, isn't it? The square of 2 is a 4. The square of 3 is a 9. Okay, now let's look at the negative numbers. The square of 1 minus 1 is a 1, correct? And the square of minus 2 is going to be a 4, and the square of 3 is going to be a 9. So we already know that this is not a 1-1 function, because this element 2, minus 2, and this element 2 both have the same image, which is 4, and hence this is not a 1-1 function. Okay, now how do we prove that? For 1-1. For 1-1. Again, I'm going to go with the same proof. Let x1, x2 belong to the domain, which is z in this case. And then I'm going to say let f of x1 be equal to f of x2. Now when f of x1 is equal to f of x2, I'm trying to say that x1 square is equal to x2 square, isn't it? So what happens here? X1 is going to be equal to plus or minus root of x2 square. So x1 is basically equal to plus or minus x2, which is true, isn't it? Because here I've gone ahead and said that minus 2 square is going to be equal to 2 square, which ideally means that minus 2 is equal to plus 2 or a minus 2, which is true, isn't it? So this proof is done. So I now know that it's not a 1-1 function. Therefore, x1 is equal to x2 or x1 is equal to minus x2. Therefore, f of x is not 1-1. If you remember, we had the same proof for the previous question. However, we ruled out this option because we were considering natural numbers, isn't it? This time we are considering integers, and exactly why we're going to take this condition into our question, and that helps us to prove that this function is not a 1-1 function. Okay, question to you, is this a onto function? Well, clearly I can see that 5 is not connected to anything, 6 is not connected to anything, 7 is not connected to anything. So basically this is not a onto function. I can just pick up an example and then tell them that this is not an onto function. I'm going to write the same proof for onto. We know that for onto. Okay, 5 belongs to Z, isn't it? 5 is an integer, but there exists no element A in the domain Z such that A square is equal to 5. Correct? Therefore, f of x is not onto. Okay, so I have gone ahead and proved that this particular function is neither 1-1 nor an onto function. Okay, great. Now we do know the next question, isn't it? It's the same thing with the relationship being from real numbers to real numbers. Let's see. Yes, there you go. There you go. So this time I'm gonna pick this up. It's the same function, but now it's from real numbers to real numbers. All these, if you can see, natural numbers, Z, integers, real numbers, all these are in bold. Okay. So the function given to me is from real numbers to real numbers, correct? And what do we have the function as? F of x is equal to x square, correct? Now let's go ahead and prove this. Before I can actually prove this, let's look at the situation here. This is my real numbers R, and this is again my real numbers R. Both being real numbers, it'll have all the decimals, the rational, irrational numbers, 1, 2, 3, everything in this, and this side also is going to have everything in it. So is it a 1-1 function? No, it's not a 1-1 function, because the square of any number will always give me a positive number, isn't it? So even if I square a negative number, something like a minus 2, which does belong to the real numbers, I'm going to get a 4. And when I square 2, even that is going to give me a 4. So there you go. It is not a 1-1 function. Okay. But is it an onto function? It's not an onto function, because all the negative numbers when squared will give me a positive number. So what is being squared to get you a minus 4? Nothing. We cannot square anything to get a minus 4, isn't it? And exactly why this is not a 1-1 function and not an onto function. Let's do the proof. The proof remains the same. Let x1 comma x2. I'm going to write this again. Okay. Now let x1 comma x2 belong to the domain R. Then I'm going to put a condition. Let f of x1 be equal to f of x2. That's a condition that I'm putting in. Now if f of x1 is equal to f of x2, then I'm ideally saying x1 square is equal to x2 square, which means that x1 is equal to plus or minus root of x2 square, which means x1 is equal to plus or minus x2, isn't it? So I've now gone ahead and proved that x1 is equal to x2 or x1 is equal to minus x2. This is where we understand that the function is not a 1-1 function, because it's either equal to x2 or another value which is a minus x2. Therefore f of x is not 1 1. Okay, now let's proceed further. For onto, because I already know that the negative numbers does not have any pre-image, I can take one example. Minus 4 belongs to the codomain, which is R. However, the proof is going to remain the same. However, there exists no element A such that A square is equal to minus 4. Therefore, f of x is not onto. Okay? It's not a onto function. Now let's look at the next question here. That's the question that we have. The function is being defined from natural numbers to natural numbers. However, the function now is this, x cube. Okay, it is natural numbers to natural numbers, yes, but now the function is actually changed. Okay, let's see how to prove this. So the function given to me was from natural numbers to natural numbers, and f of x is given to me as equal to x cube. Please do not apply the methods blindly. Please think before you can proceed with these kind of questions. Okay, what do you think? Is this a 1 1 function? 1 2 3 4 5, it goes on. Again, I'll have 1 2 3 4 5, it goes on. So 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. You see, they are all getting connected to a unique value in the second set or in the codomain, isn't it? And that's exactly why this is a 1 1 function. So I have gone ahead and proved to you that the function is 1 1. Okay, again, look at this example, which is 2 here. Well, what is the pre-image of 2? Nothing. 2 cannot be connected to anything, because something squared will not, or something cubed in fact, will not give you a 2, and not natural numbers. If they were decimals, I could have said that yes, might be possible, but this is not decimal, this is natural numbers to natural numbers, and hence it's not possible. The proof will remain the same. Let x1 comma x2 belong to the domain, and then I'm going to say let x1 f of x1 be equal to f of x2. Now what is f of x1? x1 cube. I'm saying it's equal to x2 cube, so therefore x1 is equal to x2. Okay, so now that I have gone ahead and proved that x1 is equal to x2, I can simply say therefore f of x is a 1 1 function. Okay, now let's prove or let's check if it is an onto. No, we have just gone ahead and proved that the function is not onto, isn't it? For onto, 2 belongs to natural numbers n. However, there exists no element A in n such that A square is equal to 2. Okay, A square is equal to 2. Therefore f of x is not onto. F of x is not an onto function. Let's look at the last question now. Okay, integers to integers. I would want you to do this by yourself. Let me tell you that this is a 1 1 function for sure, but it's not an onto function. Let me check. Yes, it is not an onto function, because you can give the same reason. 2 belongs to Z. However, that does not have an image in the domain, which is Z itself. Okay, and hence this is not a onto function but a one function only. With this, we will stop the recording for this particular video. What we're going to do is to look at more examples in the next video. Okay, so we will do more and more examples in the next video and see how exactly to prove one and onto. All right, and what we are also going to do is to practice. Okay, as I said, I have explained to you one or two questions. Please apply the same thought process on the next questions and try to check if you can get the solution. If you are not able to get the solution, keep this as a basis and try to understand how the remaining questions are being solved in probably your solution set, or you can either go for the textbooks apart from NCERT, which is the R.S. Agarwal and R.D. Sharma. You can use these textbook and see if you can understand the concepts from there. Okay, so correlate these words, whatever I'm using here, correlate them to the words which is there in your NCERT and R.S. Agarwal and R.D. Sharma, and that should help you a lot. Then too, I'm going to be doing more questions for you, and then shift to another chapter. And if you like this video, and if you want to have some changes with respect to the teaching, please let me know in the comment section. And if you like the video, please subscribe for it. Advise your friends to have a look at these videos and like them or subscribe to them. Thank you.